All right, one more kinematics example here. Here we've got a function in terms of meters where it's 10t squared minus t cubed. So if I take the derivative, I get 20t minus 3t squared. And if I take the second derivative, I get 20 minus 6t. And the question asks a couple things. What's the average velocity in the first 3 seconds? So average velocity is not the derivative. The derivative tells you the velocity at a single moment. Average velocity is just like y2 minus y1 over x2 minus x1. It's your rise over run. So I'm just going to do s3 minus s0 over 3 minus 0. This is the average velocity. So that's going to be, why did I write it so close to the edge? 10 times 9 minus 27, that's s of 3. And then s of 0 is just 0. That's kind of nice. And 3 minus 0 is just 3. So we get, I guess, 90 minus 27 over 3, which is 30 minus 9, or 21. Does that look right? Yeah, 21. So that means that on average, it's 21 meters per second. So that's the average velocity over the first 3 seconds. Now, if I wanted to find the instantaneous velocity at 3 seconds, I just plug in 3 to s prime. So s prime of 3 is just 20 times 3 minus 3 times 3 squared. So that's 60 minus 3 times 9, 27. So 60 minus 27 is 33, and that's also measured in meters per second. And so we can see that at that moment, it's going faster than its average velocity. The acceleration is just s double prime. S double prime of 3 is 20 minus 6 times 3. So that's 20 minus 18, right? So that's 2 meters per second squared. So it's still speeding up at 3 seconds because it has a positive acceleration. And now we want to figure out when the particle changes direction. So the changing of directions is going to be your velocity. And so that would be taking 20t minus 3t squared and setting it equal to 0. Both of those have a t in common. And so there's actually 2 points here. We have t equals 0 or t equals 20 thirds. So I guess, what is that, 6 2/3? Those are the 2 times where the particle is at rest. It has no motion. And so 6 2/3 is when it changes from being positive to negative. And you can check that because if you plug in a t value smaller than 6 2/3, like 5, you'll get a positive derivative. If you plug in a number like 10, you'll get a negative derivative. So you have your particle going forward until 6 2/3 and then going backwards after that. So thanks for watching. Comment. Let me know if there's anything I can do to help.